Zoom into a standard JPEG image, and it dissolves into a jagged grid of colored pixels. But zoom into a vector icon or digital font, and the outlines remain perfectly sharp. Why? Because vectors aren't stored as pixels, they are stored as pure mathematical equations called Bezier curves. To understand these curves, we start with the simplest building block, linear interpolation, or Lerp. Given 2 points, p0 and p1, and a parameter t from 0 to 1, Lerp calculates a weighted average. As t sweeps from 0 to 1, it traces a perfect straight line between them. What if we add a third point, p1, as a control handle? This is where Casteljau's algorithm shines. We Lerp between p0 and p1 to find point green, and between p1 and p2 to find point blue. Then, we Lerp between green and blue to find our final curve point, tracing a smooth quadratic curve. For complete design freedom, we use 4 points, p0, p1, p2, and p3. By nesting 3 levels of linear interpolation, Casteljau's algorithm generates a cubic Bezier curve. This elegant nested structure forms the backbone of digital fonts, vector graphics, and modern web animations. Expanding this nested linear interpolation algebraically yields the explicit cubic Bezier formula. Here, the positions are weighted by Bernstein polynomials. The parameters balance the influence of each control point. Because the formula is continuous, we can evaluate it at any arbitrary decimal value of t. Your screen is ultimately still a grid of physical pixels. When rendering, the graphics card samples the mathematical curve at the precise resolution of your display. It marks pixels inside the curve boundary as filled. When you zoom in, it simply recalculates the sampling at the new scale, keeping edges razor-sharp. This mathematical representation is incredibly efficient. A raster image grows in file size with every increase in resolution. A vector curve, however, requires only the coordinates of its control points. It takes the exact same amount of memory to store a letter whether it's on a mobile screen or a billboard. Bezier curves elegantly bridge pure geometry and computer science. By converting simple linear algebra into infinitely scalable visual art, they empower our modern digital world. Join us next time on the geometry of computer science as we explore the hidden math powering the software you use every day.